So, you've got some cool tissue images that you downloaded, but how can you tell what's what? Like, what is stroma? What is tumor? What is necrosis? Well, if you don't know any pro bono pathologists, there's actually this really cool model called CONCH. Today, we're going to be making an app using CONCH that will allow us to learn more about our images by matching the image with a number of categories that we're going to make up. So let's get into it. Okay, here's the Conch landing page, their GitHub repo, if you will. So we are here to first download the Conda environment, or basically pip install all of the necessary prereqs, including this repo itself. And we will start with doing a git clone. So I'm going to be putting stuff into the tutorials folder. So we're in that folder, and we just copy some commands here. Sometimes it's easier to have them right next to each other. If I could still anchor this, that would save time. Okay, we're better situated now. So, installation. We're going to git clone this. Actually, we can just press that copy button. Great, we're going to change directory into conch. Then let's go ahead and do this line by line. That's going to create a Conda environment called conch, which we can activate using this line. Then we can upgrade pip, which is always a good idea. And then we're going to pip install this conch repo so that we can have access to all of the methods that these guys have in here. All right, now we've done that. So we want to make this directory also. Clear our screen. We want to go to the Hugging Face model page here, which I actually have open twice, so that's fine. I'm logged in with my account, and I have already gone through the process of agreeing to all of their agreements, which will display on their main page when you get to it. So once you've gone through and put in your information and agreed to all the stuff, then you should have access to the models. And you can go to the files page and download the PyTorch model.bin file. So we're going to do that. We're going to download, and we're going to navigate to the right folder, which is going to be in the conch folder under checkpoints and conch. Save. Okay, so now that should all be good. And we have done this part, loading the model. Okay, so it should work now. So we can go ahead and go to their notebooks, which they have here. They have quite a few of them, but the one that's going to be relevant for us today is going to be their retrieval example. Okay, we have opened VS Code and navigated to the Conch GitHub repo folder that we downloaded from GitHub. And under notebooks, there's the zero-shot retrieval example, which we've opened up here. And then we're going to try to select the right Python kernel for it. So we'll press play. We have to choose Python environments, and yeah, it looks like we have it here. and it is now running this cell using our conch cond environment. It's just changing the directory to this path. And so this is going to load our model from where we put it in this folder. So that seemed to work out. And now we will look at the example image that they've provided, which is this one. It looks like it's got maybe some epithelial or tumor in there. And they've given some prompts. So these are the kind of classes that our image is going to be matched to. So it's going to be one of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we'll be able to see out of all of these in this list which one matches our image closest. So we'll load those prompts in there, and the tokenizer is just going to turn those prompts into the required latent space to match to our image. We're going to tokenize those, and yeah, it gives us the shape, which it's 10 items long. And here is where we run the model and get out the ranks and scores of the items in the list in terms of how similar they are to the image. Okay, so it's ranked photomicrograph illustrating invasive ductal carcinoma of the breast H&E stain as the highest with a score of 0.607. So we can be pretty sure that that is probably what it is, because that seems like a pretty high score. Okay, now we are on to making the Streamlit app. So first thing we're going to do is import our libraries. Then we're going to import the conch library as well, so that we have the conch functions that we need here. Then we're going to give it a page title, conch matcher. Going to make sure that the model path is consistent with where we saved the PyTorch model.bin file, so we can use that. Then we're going to load that model and the pre-processing steps, so the things that are needed to pre-process the image is also coming out of here. This create model from pre-trained function from conch. And the checkpoint path is where we have saved the model. So we put it in eval mode so we can run inference on it and make sure that we are running it on a GPU if it's available. Then we add a sidebar with a header called file input. We'll accept JPEGs and PNG files. And the patch file is going to specify our little image patch that we can get from the internet or take a snapshot of from our TCGA images. And then the search text is going to be a text area object from the Streamlit library so that we can separate each search term by just using a new line. Then we're basically ensuring that there is a patch file and that there is text in the search text box before we go on and do, before it processes them. Then we'll load the image using PIL, the PIL image class here, and pre-process it using the pre-processing steps that we got from the model. And resize it so that it's not gigantic, so when we look at it. Then we want to load the search terms list and tokenize it. And then we're ready to run the model. So we go ahead and we run the model to get the image embeddings and the text embeddings, and then we calculate the scores there. So this is same stuff that was used in the CONCH notebook. Then we're going to save the search results and the scores as lists so that we can then save it as a pandas data frame, so it makes it nice to display in Streamlit. And we get these scores and append it to these lists here, which we then put into our final data frame by creating that pandas data frame with two columns, the search term column and the similarity score column. And then we go ahead and do Streamlit data frame, so it will show up on the page. Okay, so now we create a terminal, and looks like we've got kind of two environments going on here. Okay, looks better. Now we're going to do Streamlit run Streamlit conch.py and command not found. This is because we need to pip install Streamlit. So we're going to do that. And then we're going to run that command again. Streamlit run Streamlit conch.py, which is the name of our Streamlit app. Okay, so here it is. And we've got our file input area here. So let's go ahead and open up a TCGA image in QPath. We can zoom in and we can get a picture over here because we're wondering what that is. And we can just drag it right in here. And then from our terms that we have put in this box, which we can modify, by the way, we can see that it is most likely stroma, which from my background, I would agree, though I am no pathologist. I'm wondering if it would detect the background. So let's see. We can just take a picture of some of this white space and see if we can fool the model. Yes, we did not fool the model. It did find the background, so that's pretty rad. How about adipose? If we put adipose in there. And I thought I saw some over here. Yeah. Yeah, doing a really good job here. So that's pretty awesome. I think it's done very well, and it's nice to have a little interface here to interact with. I would really love to hear if you guys had ideas of other domains that this sort of thing could be applied to besides histopathology. I'm sure there's a lot of different PubMed publications that have covered those sorts of things, and it might be kind of interesting to see if we can maybe create our own data set using a similar method and train Conch to on some other domain. So if that sounds cool, then leave a comment down below, and I'll see you next time.